Hi, this is Nico. And welcome to my channel.
This video will introduce you to the principles of drive cloning and drive imaging. We'll cover a few basic concepts, look at the principles of imaging and cloning, and finally get into the question of which is better for your purposes. Cloning and imaging is really about managing the system and boot partitions of an operating system, in this case, Windows. A driver partition that contains only data files does not need to be cloned or imaged. Data files can be copied or backed up simply by using ordinary file operations, such as drag and drop from inside Windows. Using cloning or imaging tools adds an unnecessary layer of complexity to an otherwise simple procedure. However, if you're copying a drive with both an OS partition and a data partition, it's practical to use the cloning tool to copy both partitions together, rather than using a different tool for each. The difference in this case is that you need the cloning tool for the OS partition, so it's convenient to do both together. An operating system cannot be replicated simply by copying its files. There were also hidden files, boot sectors, disk IDs, and adjustments to the system registry and boot configuration file to deal with. Replicating those are the forte of what cloning and imaging tools do. Throughout the rest of this video, it's assumed the reason for cloning or imaging is because we're moving Windows, not merely a data-only drive. A clone is a hard drive or partition that is a copy of the original source drive or partition. It's a hardware duplicate, ready for immediate use. In contrast, an image is a file that contains the contents of a drive or partition. When needed, those contents can be written back to restore the state of the original source to the state it was at when the image was made. Thus, imaging is a two-step process, one step to create the backup image and a second step to restore when the need arises. The contents of the original source, including boot sectors, registry, and whatnot, is compressed and wrapped up in a kind of very large zip file. In a lot of cases, the image will be large enough that it will need to be split into multiple files, in which case the image consists of the entire file set. When you want to use that image, you reverse the operation and restore the contents of the file set onto the drive or partition. A hard drive has to be partitioned in order to be used. This is the process of subdividing the drive's available storage area into one or more sections for storing files. Windows users may be familiar with this schematic representation as used by Windows Disk Management. Your hard drive may be partitioned into 1, 2, 3, or more partitions, depending on the needs of the user and the operating system. By the way, here's a newbie tip. Don't ever say your drive is unpartitioned, unless it's completely blank. Just because you bought a new computer and haven't done anything to the hard drive doesn't mean it hasn't been partitioned. An unpartitioned drive is useless for storing anything. There must be at least one partition for Windows, and typically there will be more than one. You can copy partitions from one drive to another, rearrange the order, even copy from one partition to another on the same drive. As distinguished from a partition copy, a drive copy is really nothing more than copying all the partitions to a new destination and adding a disk boot record. It's possible to even have a partially partitioned drive, where some of its space is left unallocated and unused. We won't go into the pros and cons of various partitioning strategies, but it's only being mentioned here to make you aware that the same cloning or imaging principles can be applied to individual partitions as well as entire drives. For simplicity, most examples in this video will illustrate drives as a whole, but understand that it's just as valid to apply the same techniques to partitions individually if you want to. Many people seem to think partitions on a GPG drive are somehow different than on an MBR drive. This isn't so. Regardless of whether they are on a GPG drive or an MBR drive, partitions use the same identical structure. What is different is the partition table. That's an index at the front of the drive that catalogs where the partitions are on the drive. GPT and MBR are styles of partition tables, not styles of partitions. Most modern computers come with drives that use a GPT partition table. Drives using an MBR-style partition table were common prior to Windows 8, and are now sometimes referred to as legacy drives. There are pros and cons to both partition table styles, but if you have Windows 7 or later, your OS can work seamlessly with drives of either partitioning scheme. If you have multiple drives, you can even mix and match the styles, using both GPT and MBR drives in the same system.
2,000 years
In fact, partitions can even be cloned or imaged back and forth between GPT and MBR drives interchangeably. When doing so, however, you'll need to be mindful of any limitations of the partition table. The main difference between MBR and GPT is that the newer standard supports drives larger than 2 terabytes. Because of the limited size of its registers, an MBR partition table cannot address more than 2 terabytes. And contrary to popular belief, GPT is not a prerequisite for Windows 10. Windows 10 can indeed be installed on an MBR drive if you desire, though if left to make its own choice, the Windows installer will default to the GPT style when it sets itself up. A complete discussion of the pros and cons of GPT versus MBR is beyond the scope of this video. It's being mentioned here merely to point out that the partitions are the same. Modern cloning or imaging tools understand both styles of partition tables, and so the way these tools work will be similar regardless of which partitioning style you are working with.
Much later.
In each case, you'll decide which is the best method to launch your cloning or imaging program. Many programs have a Windows component for launching from Windows, and all must have some method of creating alternate boot media, sometimes called rescue media. This is a bootable CD or bootable USB stick that you can boot from if you can't boot into Windows for some reason. For example, if your hard drive crashes and you want to restore from an earlier image, you'll need to be able to boot from a CD or a USB stick to get to your image restore program. So, depending on the task in your particular situation, you may be able to launch the program from Windows, or from a USB stick, or from a bootable CD inserted into the computer's CD-DVD drive, or a CD inserted into a portable CD-DVD drive. Bear in mind that different computers have different procedures for booting from external media, so you'll need to determine how it's done on your particular computer. If you have a new Windows 10 computer, for instance, you may need to fiddle with its secure boot and UEFI versus legacy settings before it will allow you to boot from a CD or USB stick.
2,000 years later.
This animation shows the process of cloning one hard drive to another. The source is the old hard drive already in the computer. The destination is a new drive, either connected internally if your computer has a second drive bay, or connected in an external USB case or adapter if you're on a laptop or you don't have a second internal drive bay. Choose your method of launching the cloning program, and with the new disk connected, turn the computer on and start the program. Follow your program's instructions to clone everything from the original drive to the new drive. The copying phase may typically take anywhere from 10 to 30 minutes, depending on the amount of data to be copied. When the program has finished, shut down the computer, remove the original drive, and install the new drive in the same spot as the original. Warning: do not leave the original drive in place and try to boot from the clone drive. Always get the computer up and running as a single drive computer first. After the clone has successfully set itself up, you can reintroduce the original drive as an accessory drive if you wish.
Much later.
Making a backup image of the original source drive is very similar to the procedure for making a clone, except the contents are stored in a file or a set of files, instead of immediately being written to a new drive. This image can be very large and may encompass multiple files. As they are files, they can be stored anywhere ordinary files can go. They can be stored on a set of DVDs, or somewhere on your network, or on an external USB drive, or on a second hard drive in the computer, or if the source is a partition, you can even store them on another partition on the same hard drive as the source. One advantage of imaging is that you can save more than one image on your storage drive, subject to available disk space, so you can keep multiple images made at different times before having to delete earlier images.
Much later.
Choose your method of launching the cloning program, and with the storage drive connected, turn the computer on and start the program. Follow your program's instructions to create an image. The program will copy the contents of the original drive, compress them to save space, and store the contents in a file or set of files. This may typically take anywhere from 10 to 30 minutes depending on the amount of data to be copied. When the image has been created, you can shut down the program. Remember that this is just an image, not a clone. It isn't good for anything just yet, but it becomes useful if you should ever need to restore today's state of the operating system at some point in the future. If Windows becomes corrupted for some reason, the image can be restored back onto the original drive. Or if your existing drive dies or you want to upgrade to a larger or faster drive, the image can be restored onto the replacement drive.
2,000 years later.
This animation covers how to restore from an image you've previously made. If you're replacing the old drive, remove it and install the new drive in its place. If you're just rolling back a Windows system that has gone bad, leave the old drive in place and overwrite it. Either way, for this phase you have to boot from Rescue Media, a bootable CD or bootable USB stick. You can't replace the operating system if you're actively booted into it, so you have to boot from the Rescue Media instead. Different computers have different procedures for booting from a CD or USB stick, so you'll need to determine how it's done on your particular computer. Follow your program's instructions for restoring from an image. This may typically take anywhere from 10 to 30 minutes depending on the amount of data to be copied. When it's finished, close the program. Remove your Rescue Media and reboot the computer from the newly restored drive. Warning: if you have multiple drives in your computer, remove them and get the computer up and running as a single drive system first. After the restored drive has successfully set itself up, you can reintroduce the other drives to the system. Here's an often misunderstood concept. Despite the clone terminology, these utilities do not make an exact bit-for-bit replica of the original source. While that may be desirable if you're a forensic investigator, for the rest of us we don't actually care if it's an exact copy. All we care about is whether it boots and behaves just like the original did. An exact clone won't do that. When Windows is installed, it's tied to a number of system characteristics, including the port and disk ID or GUID. The registry is set up to identify locations on this particular drive. When the installation is copied to another drive, that copy needs to be adjusted for any changes in the port, disk ID, GUID, partition location, just to name a few. And once you start making adjustments, you no longer have the definition of an exact clone. Successfully cloning an operating system involves 4 major steps. First, the cloning program must be capable of creating the partition and the file system within that partition. Not all programs get this right. When inspecting partition tables and partition boot sectors, on occasion I've spotted mistakes made by the cloning program in certain scenarios, even from some of the more popular programs. Sometimes the errors are serious enough to cause partition corruption, but Windows is resilient enough that it can often ignore minor errors, so it's not unusual for these programs to skate by despite small mistakes. The message here is that if one program seems to have trouble in your particular scenario, don't be afraid to try a different program. What works for others may not work in your situation, and vice versa.
2,000 years later.
Second, the cloning program needs to copy the contents of the source partition to the destination partition. This is the easy part, and every program should at least be able to get this part right. The next 2 steps are more difficult, and are what typically sets good cloning programs apart from the rest. In the third step, the cloning or imaging program must configure the clone so it knows where to boot from. The boot process starts from boot files in the startup partition, and from there the boot configuration data, or BCD, tells the boot process where the actual Windows partition is, so it can continue the boot process. In Microsoft terminology, the startup partition is called System, and the Windows partition is called Boot. Depending on how Windows is installed, these may be on different partitions, or they may both be on the same partition. When Windows is moved or copied, the BCD in the System partition often needs to be reconfigured for the location of the new boot partition. If you're cloning to a hard disk that's in an external enclosure or otherwise not in its final location, the cloning program needs to configure the BCD for where it's going to be, not where it is at the time of cloning. If the cloning program guesses wrong, you may end up with a boot configuration error message suggesting you need to do a repair install. Note that if, at the time of cloning or image restore, the target disk is already in its intended ultimate location, the program has a better chance of getting the adjustments right. Fourth, you want the clone to see itself as the C partition. You don't want it to think the source partition you copied from is still C. Drive letters are not hard-coded on the disk. They are defined at boot time by the OS being booted. You'll find these specifications in the registry of the booted OS, in the H key, local machine, system, mounted devices registry key. Here you'll see the C partition is matched to a partition with a unique partition signature. When the registry is cloned from the source, you want this to be changed to be the clone's partition signature. Otherwise, the clone will think the original source partition is still C. There are two ways to achieve this, and different programs may use either method. One way is to try and figure out what the clone's partition signature is and substitute that into the registry as it's copied to the clone. The other way is to invalidate or clear the registry entry and let Windows rebuild it for itself. When the clone first boots, if there is no previous entry for C, Windows will attempt to rebuild the registry key. Since it no longer has any knowledge of what used to be C, it will usually call its own partition C and set that partition signature in the registry. Without the BCD and registry tweaks, an exact clone will expect to still be booting on the original drive. With the tweaks, you won't have a literal clone, but you will have a close enough copy that can actually boot. Okay, so which is better, making a clone or making an image? The answer depends on what your objective is. If you're upgrading your existing drive to a larger or faster drive, you can make an image, but then you'd immediately be restoring it onto the new drive anyway. In that case, choose cloning to save a step. If your aim is to make a backup in case something goes wrong with your existing installation, you could make a clone, but then you'd have a dedicated hard drive sitting around, unavailable for use for any other purpose. In that case, use imaging. Images occupy less space than clones. An image of a 500 gigabyte drive with 120 gigabytes of used space will, with a typical 50% compression ratio, end up as a 60 gigabyte file. If your storage location is 500 gigabytes, you could fit 8 images on it, capturing the state of your Windows system on 8 different dates. That could be handy if the most recent image turns out to be unusable for some reason. In contrast, a clone of that same 500 gigabyte source drive will still occupy 500 gigabytes, and you'll only have one backup. Imaging is also marginally more reliable than cloning. The cloning operation requires the cloning program to guess what tweaks need to be made to the copy before the destination drive is in its final resting place. Most of the time, the better programs will get it right, but not always. In contrast, when an image is restored, it's easy to have the destination drive already in its ultimate location, so the program can be more certain about how to tweak the copy to make sure it works. So there you have it, a quick introduction to the concepts of cloning and imaging. Hopefully this will be useful to you in developing your own personal strategy for backing up Windows or for when you need to transfer Windows to another hard drive or solid-state drive. There is a wide array of good programs available, including several which are free, but no attempt has been made to advocate for any particular program. You'll need to learn how your program of choice works, especially in this age of Windows 10 and the roadblocks meant to hinder users from booting from external media. Most will require you to at least disable Secure Boot, and some may also require booting in legacy mode instead of UEFI. This video doesn't cover the ins and outs of specific tasks or operations, or what to do if a particular program doesn't work right. If your project is complex, sometimes an OS partition will get copied but won't boot properly. That doesn't mean you have to recopy the partition. Usually you just need to fix the boot configuration tweaks. That's most often the cause of problems, and though it isn't hard, it is beyond the scope of this introductory video. The goal here has been to give you the bird's-eye overview of how the concepts and pieces fit together while not getting bogged down in program-specific details. Hopefully this has given you a better grasp of the fundamentals of the process. Finally, one last word. I did say I wouldn't get into partitioning strategy, but I feel compelled to mention one tip that can fundamentally impact your backup imaging strategy. By default, Windows computers come with one giant C partition that is used for the OS, programs you install, and all your personal documents. Word docs, spreadsheets, downloads, music, photos, everything. I strongly recommend that you create a separate partition for your personal data files. Leave the C partition to Windows and installed programs, and use a separate partition for your music, photos, and other documents. In Windows, it is really quite easy to change the default locations for your various data folders. This screen capture shows how simple it is to move your default user data folders from partition C to partition D.
2,000 years later.
Commingling your documents with the operating system makes it more difficult to restore from an earlier image should the need arise following a bad program update or if Windows throws a fit for some reason. Commingling your documents means they would have been embedded in your last backup image, but since the image was made, some of them may have changed. Your data usually changes more frequently than the OS. You'll need to temporarily copy that data somewhere else while you restore your OS partition from the backup image. But it can be difficult or time-consuming to identify and locate just the changed documents, so you'll probably opt to copy all your data, restore from your image, and then copy all your data back. Compare that to the simplicity of having your documents on a separate partition. If something goes wrong with Windows or any of your installed programs, just restore from your backup image. Job done. You don't need to touch your documents. In addition, keeping your documents out of the OS partition means images of the OS will be much smaller. That means they'll take less time to make, less time to restore. You'll be more inclined to keep them up to date, and you can save more iterations of them before you have to start deleting old images to recover storage space. Your OS doesn't change as rapidly as your personal data, so by commingling your data with the OS, you'll either waste time and storage space making frequent backup images, or you won't back up often enough to keep up with your ever-changing data. I've been separating my data since my first DOS 3.3 computer in the 1980s, and it's always seemed so obviously beneficial that it absolutely baffles me how otherwise intelligent tech proponents fail to see the utter practicality.